Welcome back to class. Today we are going to look at the arrangement of electrons in shell. Last time we used the KLM configuration to fill electrons in shells. Now let me take a recap from the last class. For instance, let's start with very simple. Let's say boron. Boron is 5. Now, if you want to use the KLM configuration, you will discover that boron is K is 2 and L is 3. 2, 3. Now, for the orbital diagram, you have to now start drawing the shells. Now, the first one, remember it has 2. You designate it this way, 2. Now, the second one, it has 3. You designate it this way, 1 and 3. That is the shell of what? Boron, 2, 3. Are you getting me? Now, let's take another example so you understand better what I'm saying. Let's take another example. Let's say sodium. Sodium is Na. Sodium is 11. Now, from our KLM configuration, which I know you're used to in the class, sodium is what? 281. 1 electron in the outer orbital, in the outer shell. Now, K, you start with this, you have what? 1, you have what? 1, 2. Now, the 8, you have what? 2, 2, 2, and 2. And the outer electron is what? 1. 2, 8, what? 1. Are you seeing that? Let me take one more example. You're going to use something, let me use something like neon. Neon is element number 10. Now, this is what? 2, 8. Now, this 2, 8, if you want to draw it, still very simple. You do 1, 2. Are you there? Then the outer one that has 8, you pair them in pairs. 2, 2. All the orbitals are filled. Now, in a situation whereby all these orbitals are filled without any space, we call this kind of elements, we call them noble gases. Noble gases or unreactive gases. Now, we have them in helium, neon. We also have them in argon. Argon is 18, and argon is 288. Now, with this, I want to teach you a short trick for you to know the period and the group a particular element belongs to. Now, let's use neon for example. Let's know the particular element. Let me use, let's say, sodium, the one we've used before. Sodium is 11. Now, you have 2, 8, 1. For you to know the particular period this element belongs to, if you check your periodic table, period what and what? Group what? Now, for you to know the period, you count the number of what? Shell. 1, 2, 3. Period 3. Then for you to know the group, the group corresponds to the outer number of electrons, which is 1. So if you check your periodic table, you see that sodium belongs to period 3 and group 1. Let's try for other elements. Let's see if this our postulate is going to work. Let's look at, for instance, let's say aluminium. Aluminium is 13 and it has 283. Now, from this, you can easily say that the period is what? Counting the shell, 1, 2, 3, period 3, and aluminium is definitely going to be in what? In group 3. You can confirm this from your periodic table. Now, finally, let me give you one more element. You can do others by yourself and confirm these are postulate. Let's say oxygen. Oxygen is what? 08, and oxygen is 26. From our previous video, you already know how to do this. Now, the question is, what period does oxygen belongs to in the periodic table? Now, you count the number of shells. You discover that oxygen belongs to group 2, period 2, and what will now be the group? Because it has 6 electrons in the outermost shell, oxygen belongs to group 6. With this, you can also use the KLM configuration to actually tell the group and the number of period that an element belongs to without actually looking at your periodic table. Thank you for attending class today. Don't forget to like, share, and subscribe for some expository lessons in chemistry. See you in the next class. Thank you.